Hi everybody, today we are going to talk about arcs and chords of circles. Okay, so we're going to start by talking about 4 really important facts about arcs and chords. So I'm going to zoom in for these first 2. And remember, this line segment from A to B or D to C, those are examples of chords. And if you follow along the outside of the circle, the curved part is the arc. So this says if 2 chords are congruent, so let's imagine that this chord is congruent to this chord, then the corresponding arcs are also congruent. So these 2 would be congruent. And that works for the exact opposite order as well. If you know the arcs are congruent, then the chords must be congruent as well. Now let's look down at our next fact. This says if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So let's look at this fact in terms of the picture. If a radius, so the radius here would be CA, or CB is also radius. So remember, radius goes from the center out to your circle. Or a diameter. BA would be the diameter. A diameter has endpoints on your circle, but also goes to the center. So if either of those types of segments are perpendicular to a chord, here is your chord, and I know that they are perpendicular because of this 90-degree box. This box, remember, symbolizes 90 degrees. Then it bisects, which means to cut in half, 2 different things, the arc and the chord. So here's the chord. So it will bisect the chord, meaning it creates 2 congruent parts, but it also bisects the arc. So the arc will have 2 congruent parts as well. The last fact is 2 chords, so you can see in this picture that'd be A, B, and C, D, are congruent if they are equidistant, meaning equal distance from the center. So if you see a picture like this, and we know that this distance is the same as this distance. Now, these 2 chords are equal distance from your center, so we know that chord AB is congruent to chord CD. So once again, if the chords are equal distance from the center, then the chords must be equal themselves. All right, so now we're going to see if we can use some of these facts that we know. So this says circle O has a radius of 13 and chord CD is 24. So I'm going to zoom in on this picture and we're going to figure out what we know. So once again, it said the radius is 13. So I'm going to label this 13. And I notice that I have another radius here that is perpendicular to a chord, meaning it bisects the chord and it bisects the arc. I know that from fact 3 from the previous slide. Now it says chord CD is 24. Well, if the total chord is 24 and it has been cut in half, I know that that means that each of these smaller segments are 12. Okay, now we've labeled just about everything we know. Let's look at the question. They say if the measure of arc CD is 134, find the measure of arc CB. Well, I know if the total is 134, then this arc CB is just going to be half of that. So I'm just going to do 134 divided by 2 and see how many times it goes in. So let's do a little bit of long division. And we get 67. So arc CB is 67 degrees. And that's only because we know that it has been bisected or cut in half by radius OB. The last thing they would like us to find is OX. So that's this segment right here. Well, I know it looks like it's a little tricky to find, but if you look at what we have right here, it's a right triangle. So I'm going to redraw just that one triangle so we can work with it a little bit easier. Try that one more time. There we go. Okay, so this is point C, this is point X, and this is point O. And we know from our picture this was our radius, it's 13, and we knew that this segment is 12, and they want us to find this. Well, this is a right triangle. We can always use Pythagorean theorem. The most important thing to remember is that this value must be your C value. So we can do A squared plus B squared equals c squared, and then all we have to do is simplify. If I subtract 144 from both sides, I get x squared equals 25. Remember, the way you undo a square is by taking the square root of both sides, and x will equal 5. So that means that OX, line segment OX, has a length of 5. So always look for ways that we can utilize a right triangle because we know how to work with right triangles. All right, why don't you go ahead and pause the video and see if you can give this problem a try. All right, let's have a look. So here you can see that I gave you a little hint to actually draw in our own radius, RV, or you could do RT. So with the information we know, the radius is 16. And once again, we have a diameter this time that is perpendicular to the chord. So remember, it bisects the chord and the arc. And we know that TV, this entire chord, is 22. So half of that must be 11. So the first thing they wanted us to find was the measure of arc UV, but we know the total arc of TV is 110, so you just do 110 divided by 2, and you get 55 degrees. So it's going to be half of that because it has been bisected. Now to find RS, once again we have a right triangle, and it looked something like this. Here's R, here's S, and here's V. We know this is 16, we know this is 11, and this is X. So we can use Pythagorean theorem again. And here we just need to start simplifying. So we know that 121 plus x squared equals 256, which is 16 squared. And then I'm going to subtract 121 from both sides. And then I'm going to take the square root of both sides. And then I'm going to start simplifying this radical. So remember, we can make a little factor tree. So if I divide it by 5, it's at 5 and 27. So 3 and 9 and 3 and 3. So remember, we can list out our prime factors. 3 times 3 times 3 times 5. Circle the pairs. 1 escapes. And what we have left is 3 times the square root of 15. So that is the length of RV. But remember, this is stuff that we did in the past, in the previous section. Pythagorean theorem should be something that we're very comfortable with. So from here, you should be good to go. Okay, let's try one last example together. So here we are told that the radius of circle G is 26, and they want us to find two things. They want us to find AC and then ED. So I'm going to zoom in here. Once again, the radius is 26. So that means that this distance is 26 and this distance is 26. So if now let's also look at what we have here. So we can see that we have something going from the center out. So it's acting kind of like a radius, and it is perpendicular to this chord. So I know that since it's perpendicular, it's actually going to bisect the chord. So I'm going to do this and this. Now, the same thing would happen on this side, but another really important thing to notice is that these values are the same. These two chords are equidistant from the center. They are both 10 units from the center, which means that AC is actually congruent to FD. So if this side is also bisected, all of these little segments are going to be congruent. AB is congruent to BC, which is congruent to FE, which is congruent to ED. All of them are congruent. So we used two things we know. We used the bisecting of the chord, and we learned that the chords are actually congruent because they are equidistant from the center. Now, from here, you can see that they want us to find AC and ED. So we're going to start by finding one of these shorter values. We'll call this X. So we have a right triangle again. I'll zoom out, and I'm going to redraw my triangle. Here's my right angle. So this is X, this is 10, and this is 26, so we can use Pythagorean theorem again. Just make sure 26 is your C value. So here's what we have. I'm sorry, I skipped a step. It should be 10 squared equals 26 squared. And then 26 squared is 676. So then we're going to subtract 100 from both sides. And actually, if you take the square root of 576, it is actually a perfect square. The square root of 576 is 24 exactly. So I know that all of those smaller segments are 24. So if I want to find the length of AC, well, AC is just going to be 24 times 2 because it has 2 of those smaller segments. So AC is going to be 48. But ED, if you look at where ED is, it's one of the shorter segments. So ED is just going to be 24. All right, so that is all for today's video. Thank you so much for watching.